Hey guys, so today we're going to look at converting polar coordinates to rectangular coordinates and then converting rectangular coordinates to polar coordinates. So when we want to take a polar coordinate, remember a polar coordinate is in terms of r and theta. So we want to turn that r and theta into some x and y. Okay, so let's look at our x and y axis here. Okay, so remember that if we have an x value and a y value, that creates this point. Well, this distance here, remember, represents your r value, and the angle at which it is increasing here is your theta. Okay, so if I want to think about some equations in terms of r, theta, x, and y, okay, so this would be your x and this would be your y. So think about this. So we've got opposite over hypotenuse. Remember that is sine. So sine of theta is going to be opposite over hypotenuse. Adjacent over hypotenuse is going to be cosine. So cosine of theta is going to be your adjacent value over your hypotenuse. And then tangent, remember, is tangent of theta is your opposite over your adjacent. So these three things right here are going to be so important. So for this first one right here, if I know theta and r, I can find my y value, right? So if I solve this equation for y, it would just be r times sine of theta. Right? If I solve this equation for x, this one would just be r times cosine of theta. So I could use these two pieces of information to help me find my x and my y. So if I have an r and a theta, and I want to turn it into a rectangular coordinate, I can plug them in. So to find the x value, I am going to say r times cosine of theta. To find the y value, I will say r times sine of theta. And that will give you your x and y coordinate. Okay. The other thing that we could do, and this is going to be when we convert backwards, when we go from rectangular to polar coordinates, is using the Pythagorean theorem. So the Pythagorean theorem, remember, is x squared plus y squared is going to be equal to your r squared. So x squared plus y squared equals r squared. Tangent of theta is going to be equal to y over x. Y equals r sine of theta, and x is going to be equal to r cosine of theta. Those are our four equations that we need to remember. Okay, so we're going to convert these from polar coordinates to rectangular coordinates. So we're going to go from polar to rectangular. Alright, so here is my r and here is my theta. So I want to find x, and x I'm going to say r times cosine of theta. So I'm going to say 2 times cosine of 5 pi over 3. Cosine of 5 pi over 3 is a 1/2. So this will be 2 times 1/2, which is just going to be a 1. Okay, to find the y value, I'm going to say 2 times sine of 5 pi over 3. So sine of 5 pi over 3 is going to be a square root of 3 over a 2. So my y value here is going to, oh, I think that's a negative, I'm sorry. So it'll be a negative square root of 3 over 2. So this is going to be a negative square root of 3. So the x coordinate is going to be 1 comma negative square root of 3. Okay. All right, I did this one for me. So here is my r, and here is my theta. So I'm going to say x is going to be equal to r cosine of theta. So I'm going to have a negative 6 cosine of 3 pi over 4. So cosine of 3 pi over 4 is a negative square root of 2 over a 2. So that'll be a positive. So this will be a positive 3 square roots of 2. The y value is going to be r sine of theta. So r is a negative 6 sine of 3 pi over 4. So sine of 3 pi over 4 is a square root of a 2 over a 2. So this will be a negative 3 square roots of 2. So the x coordinate is going to be a 3 square roots of 2, and the y coordinate will be a negative 3 square roots of 2. Okay. All right, let's do one more. Okay, so the x coordinate is going to be r cosine of theta. So this will be 2 cosine of pi over 2. Cosine of pi over 2 is 0, so this is just going to be a 0. The y coordinate here is going to be r sine of theta. So this will be 2 sine of pi over 2. Sine of pi over 2 is just going to be a 1, so the y value will be a 2. So this will be 0, 2. Okay. Alright, so that is changing from polar into rectangular coordinates. Now what if we went from rectangular to polar coordinates? Right, so remember we've got what our x is going to be equal to r times cosine of theta. Our y is going to be equal to r sine of theta. Okay, we don't want that because we're wanting to change it from rectangular to polar. So what about x squared plus y squared is going to be equal to an r squared. So I've got my x and my y. So if I did take the square root of both sides, I would be left with the square root of x squared plus y squared. Here, remember your r is a distance, so it's a radius, so think about that. It's always going to be positive there. And then you'll have tangent of theta is going to be equal to y over x. So remember, theta would be tangent, the inverse tangent of y over x. So to change from rectangular to polar, these are the two equations that you need. Okay, this is what you'll be using. Alright, so let's do this value, 2 and 2 square roots of 3. Okay, All right, so this is x and a y here. So this is in what quadrant? It's going to be in the first quadrant, so it'll be in quadrant 1, right? Okay, so let's think about that always. All right, so if it's in quadrant 1 here, it's going to be, I need to find my r first. So to find my r, I will say 2 squared plus 2 square roots of 3 squared, and then I'll take the square root of that. So what's that, 4? 4 times a 3, so that's 4 plus a 12, right? And then that's a 16, so square root of 16 is a 4. So your r value is going to be a 4. So to find your theta here, you will say inverse of tangent of your y value over your x value. So this will be inverse tangent of square root of 3, of just a square root of a 3. So inverse tangent of square root of a 3 is just going to be pi over 3. So the rectangular coordinate will be 2 comma 3, or 2 square roots of 3, I'm sorry. And then the polar coordinate will be 4, and then pi over 3. Okay? What else could it be? Or it could be a negative radius, right? So it could be a negative 4, and then I would add pi to that. So pi plus pi over 3, so that's going to be a 4 pi over 3. So it could be negative version 2 there. Okay? So it could be either of those answers. Either of those answers will work, right? Because you've got a negative r there. Because remember, negative r would be down here. So if you were to graph the 4 pi over 3, then the negative version would be back in quadrant 1 up there. Okay, so let's think about this for a second. Where is 3 square roots of 2 over 2 and a negative 3 square roots of 2 over 2? So this is going to be in the 4th quadrant. Okay, so to find my r, I am going to say the square root of 3 square roots of 2 over 2 squared plus a negative 3 square roots of 2 over 2, all of that squared. So that is a 9 times a 2, which is an 18 over a 4. So 18 plus 18 is a what, 36? So this will be a 36 over a 4. So this will be the square root of a 9, and the square root of a 9 is just a 3. So that crazy number turned into a beautiful, just a positive 3. So to find the theta that represents, so it's going to be a 4th quadrant, so it's going to be a pretty big number. Okay, so it's a pretty big angle, I'm sorry. So we'll say theta is going to be the inverse tangent of that ratio, negative 3, whoops, square roots of 2 over 3. So that's just going to be the inverse tangent of a negative 1. Okay, So the inverse tangent of a negative 1, so it'll be in the fourth quadrant, so that will be 7 pi over 4. So here is the rectangular value, and here is the polar. Okay, but remember, we could also have something that represents here. So what would that be? That would be a negative 3, and then I will subtract a 7. So I'll say 7 pi over 4 minus a pi. So I'll subtract a pi. So that'll be 4 pi over 4, which is 7 pi over 4 minus a 4 pi over 4, which is going to be a 3 pi over 4. So those are your two possible solutions there. Okay, so that's converting from polar coordinates to rectangular coordinates, and then rectangular coordinates to polar coordinates. All right, if you have any questions.